Greetings, math fans. All right, so today's topic, which is day 4 of our Sequences Series Part 2 chapter, but our topic is called partial sums. And in order to introduce partial sums, we actually need to talk about another topic before that. So again, our main topic is partial sums, but our little topic before we even start here is called limits. So that's kind of what we want to start out with here. So if you can see, we've got limits here. Okay, and basically it's our kind of our first exposure to calculus. And the notation, if you guys see the notation here, this guy right here, you'll see the limit as n approaches infinity. Now that n could go to any number, but we're going to talk about infinity because we want to say as it gets bigger and bigger and bigger and bigger, what happens. Okay, so it's a limit, and we actually say in English, I'm kind of reading this off here, in English we say the limit as n approaches infinity. It's all about approach. Okay, we don't get there. We're approaching. I mean, I've been there like 2 or 3 times, and one of my friends who's been beyond infinity, you might know him, Buzz Lightyear, but otherwise it's you approach infinity and you never get there. Okay, because infinity's not really a number. Like, you know how back in the day you said, you know, you're arguing with your brother, I'm 5 times smarter, and your brother's like, I'm 10 times smarter, I'm 50, 100, and then somebody said, like your brother said, oh, I'm infinity times smarter. Well, you really can't be infinity times smarter because it's not a number. So next time you have an argument with your brother, and your brother says, I'm infinity times smarter, you say, you know, you can't really be infinity times smarter because you can only approach infinity. Okay, you might get punched or something, but it's totally worth saying that. All right. Anyway, like I said, in other words, as n gets really large, what happens to the function? That's what I want to do. You're going to have some variable in there, and that variable is going to get huge. I want to know what's going on with that whole function. So we're going to talk about 4 possibilities. Okay, 4 possibilities that we're going to discuss here. The first one is going to be the result can be a number other than 0. And the next one is going to be 0. The next one is going to be positive infinity, and the next one is going to be negative infinity. So those are the 4 possibilities that can happen as n goes to infinity. Okay, so we're going to take a look at all 4 scenarios here. The first one, if you look at the problem here, so this guy right here, I said limit as n approaches infinity of that polynomial over that polynomial. I want you guys to understand, first of all, that -3, as n gets really big, it's like so insignificant. Same thing with the 6, right? Because as n gets bigger, the -3 and the 6 like just stay the same, and so they're totally insignificant. And even if you look at it, this guy right here, the 5 and the -n, those are insignificant too, because n squared grows just a ton faster. I mean, just put a number in there. If I put like a number 10 in there, 10 versus 10 squared, 11 versus 11 squared. 50 versus 50 squared. When you square something, that grows so much faster than just without squaring it. So here's the deal, and this is just kind of a statement here. Think of Bill Gates. If he has got $1 billion and you hand him $1, and is he going to say that he's still going to say he's got $1 billion. He doesn't say, "Oh, thanks, man. Now I got." Somebody says, "How rich are you?" He goes, "Well, I'm a billionaire in $1." It's not that $1 doesn't matter. Okay. So the rule is, so this is right here, this rule right here, if n approaches infinity, you always keep the highest degree on the top and the bottom. They are significant, and the lower degrees don't really matter, right? So this 5 and this -3 don't matter, and this -n and this -6 don't matter. So going back to that original problem right here, I can actually cross these out. They don't, because they're insignificant, and I really wind up with that limit as n approaches infinity of 4n squared over 2n squared, because the top has just the 4n squared, it's the significant part, and the bottom has the 2n squared, which is the significant part. So what I can do is I can simplify this now. That 4n squared over 2n squared is actually 4 over 2. So the answer to this whole problem as n goes to infinity is 2. And I said note that the degree is the same on the top and the bottom, because that's where we're going to have our 4 scenarios. Okay, so degree is the same on the top and the bottom. Okay, so because the answer is going to 2. Because it's going to 2, we say the series converges. That's a key word here, math fans. It converges to 2. Okay? All right, so here's our second scenario. It's almost the exact same problem, but if you notice, the degree is bigger on the bottom. right here. See this 8n cubed versus the 5n squared? It's bigger on the bottom. So again, I kind of simplified everything. I mean, I got rid of this. I got rid of these. And then I have 5n squared over 8n cubed. And if I simplify that, I get n approaches infinity, it's 5 over 8n. Now just think logically. As n goes to infinity, doesn't that, it's like 5 over 8 billion, 5 over 8 trillion, doesn't it get smaller and smaller and smaller? And doesn't it approach 0? And that's what the answer is. This gets closer and closer and closer to 0. Because it's the bottom's getting huge. Okay? And I said note here that the degree on the bottom is larger than the degree on the top. I kind of pointed that out. Okay, so if it's bigger on the bottom, that means the bottom's getting bigger, faster, and that's why it's going to 0. So this one is going to, we say that converges to 0. Converge means you're going to a value. Okay, if you diverge, that means you're going to infinity, negative infinity, or back and forth, positive, negative, something like that. But converge means I'm actually going to a value. Okay, let's look at case number 3. Limit as n approaches infinity. So it's kind of that we're doing the exact same stuff here. And what happens is, again, all this stuff cancels out here, right? And we get, and just be careful, make sure it's in descending order. Don't just cancel those first terms out. You're looking for the highest degree on the top and the highest degree on the bottom. So what happens is, after you simplify this, you get 4n over 5. And think about it. What happens when n gets big now? Doesn't the top get huge? So the entire fraction gets bigger and bigger and bigger positively. So we say this the fraction approaches infinity right here. Okay, right there, infinity. And I said no degree is on the top is larger than the degree on the bottom. So this is important. We say the series diverges. Diverges means it doesn't go to a number. Infinity is not a number. Doesn't go to a number. Okay. And number 4, same scenario as number 3, except you have a leading coefficient that's negative. That's all that's different here. So after you do all your work and you simplify it, you get this. And what happens is, instead of it going to positive infinity, it's actually going to negative infinity, because it's negative 4 billion over 5, right? It's going to a negative value. So those are your 4 categories. You're either going to a number, if it's the same, the degree is the same on the top and the bottom. You're going to 0 if the degree is bigger on the bottom. Or you're going to positive infinity or negative infinity if the degree is bigger on top, and then you have to look what the sign is, okay, of that highest degree. And that'll tell you if it's going to positive or negative. Okay, so with that in mind, our main topic, ta-da! We'll highlight this. Our main topic is called partial sums. We can look at a sequence of numbers and identify what the sum is by finding the sum of the first few terms and creating a general equation. We've done that before, creating a general equation. But what we're going to do is we're going to actually look at the sums of those, so we're going to add them together. Then we'll take the limit of that general sum equation as n approaches infinity. This is called partial sums. Okay? So, real quickly, math fans, though I don't have my calculator up, literally I'm going to add these terms together. So my first S sub 1 is the very first thing. What happens is you literally put 1/2 here. That's the first sum. All right? And then I'm saying 1/2 times, or not times, 1/2 plus a negative 1/10. So I know it's subtraction, but 1/2 minus 1/10 is, and always simplify it. Hit your fraction button on your calculator and simplify it. Okay? You have to do that. And then I'm going to subtract 1 over 40. So I'm just going to hit minus 1 over 40, and I get 3/8. And I'm going to subtract 1 over 88, and I get 4/11. And I'm going to subtract 1 over 154, I get 5/14. And I'm going to subtract 1 over 238, I'm going to get 6 over 17. These are so easy. I'm going to write this. If you can't get these, you don't know how to use your calculator. Okay? I mean, seriously, this is so easy. Literally, you put the first 6 sums, and the first one is easy. But don't forget that. Kids sometimes forget to put S sub 1 as the very first term. All right? Make sure it's basically just you put the first term, and then you add the next term, and you add the next term, and you add the next term, and next term, and next term, and you get your answer. Okay? Super easy. The hard part now is actually getting, and that's not even that hard, I want to get a general expression for my S1 through S6. So if you look at it, I mean, do you guys recognize the top of this, the 1/2, the 2/5, 3/8, blah, blah, blah? Isn't the top arithmetic? So if I want to look at the top, it's arithmetic. So you're going to say Oh, it's a sub n equals a sub 1 plus d, which is 1 times n minus 1. Right, if you guys remember that equation. So we get a sub n equals, if you simplify that, you just get n. And for the bottom, it's also arithmetic. And you recognize that because it goes up by 3, starting with 2. So it's a sub n equals a sub 1 plus d, which is 3 times n minus 1. And you simplify that, and you get 3n minus 1. So your s sub n, which I'm going to put up in this top blank here, is the top n over 3n minus 1. That gets you another point. Okay, the sums get you a point, and come up with a general term gives you another point. Now what I want you to do is, I'd like to see this work. You're going to say, oh, what the limit as n approaches infinity of n over 3n minus 1. Okay? So just as I did before, you're basically, you ignore that negative 1, and you really have limit as n approaches infinity of n over 3n. Right? Because that negative 1 doesn't mean anything. And you can simplify then that as 1/3. And that's your answer. It's converging to 1/3. Okay? I mean, you kind of see, look at the first sum is 1/2. Then 2/5, 3/8, 4/11, 5/14, 6/17. 6/17, 1/3 is 6/18. So it's going to get closer and closer and closer to 1/3. That's the sum. Okay? It's not bad. Let's do the next one. Again, you're going to add these together. So the very first term you're going to write down here is 2/3. And then you're going to add 2/9. So you're going to get 8/9. Then you're going to add 2 over 27. You get 26 over 27. You're going to add the next one. You get 80 over 81. Add the next one, 242 over 243. And the next one is 728 over 729. Okay, so I look at the 2, 8, 26. Don't really know that one, but boy, I look at that 3, 9, and 27. So let's take a look at the bottom first. Can definitely do something with that. I see it goes up by multiples of 3, so it's actually geometric. So it's a sub n is equal to 3 times 3 to the n minus 1, right? A sub n times r. A sub 1 times r to the n minus 1, and I can simplify that to say 3 to the n. That's my bottom. Well, I don't really know what the top is, but isn't it 1 less than the bottom? Right? The 2 is 1 less than the 3, the 8 is 1 less than the 9. So really, this is for the top. It's really the bottom minus 1. So I can say 3 to the n minus 1. So if I write my term here now, it's going to be 3 to the n minus 1 over 3 to the n. That's your general term. Pretty easy. Now remember, I want to do limit as n approaches infinity of 3 to the n minus 1 over 3 to the n. Well, doesn't that negative 1 actually doesn't really do anything, right? And what's 3 to the n over 3 to the n? Isn't that just 1? So this converges to 1. But look at the number. 2/3. I mean, look at it, 728 over 729. Isn't that really, really, really close to 1? Okay. And then here, the last one. I put the sums here. It's going to be 0, 3/4, 4/3, 15/8, 12/5, and 35/12. Now here's the deal. This doesn't look like a pattern. It goes from 4 down. Look at the denominator. 4 to 3 to 8 to 5 to 12. So remember what we talked about back in the day. You have to unreduce sometimes these fractions. Okay. Well, what if I multiply this one by 2 over 2 and do 8 over 6? That kind of has a pattern. 4, 6, 8, 10. Right? I want this one to be 10. So it's 24 over 10. And what about that 0? Well, it needs to be a 2 on the bottom, right? Can that just be 0 over 2? Ah, very interesting. So definitely the bottom Let's do the bottom first. The bottom can be arithmetic. So you can say a sub n is equal to 2 plus 2 times n minus 1. So that's equal to 2n. The top is actually more tricky. The top, I don't really recognize that. So what I'm going to do is I'm going to list some of these terms out. 0, 3, 8, 15, 24, and 35. The difference between these, 3, 5, 7, 9, 11. The difference between these, 2, 2, 2, 2. So this is n squared. So you can use your calculator, and if you do that, plug it all in as you've done before, you get n squared minus 1. There's your top. So S sub n is n squared minus 1 over 2n. N squared minus 1 over 2n. Okay? So let's do limit as n approaches infinity of n squared minus 1 over 2n. Well, this is out of here, and I wind up getting this. Limit as n approaches infinity of n squared over 2n, which is n over 2. What happens? Doesn't it go to infinity? It gets bigger and bigger and bigger. So that is going to infinity. So that's what you're going to tell me. You're going to say it diverges, and you don't need to fill in the sum because you don't say the sum goes to infinity. Okay? So that is partial sums. It's really not difficult. The hardest part is actually finding that general term, and then you got to take the limit to find what happens as n gets really, really, really big. Okay, so really the next part of this this note sheet here is just to practice limits as n goes to infinity. Okay, so again, we've done 3 different examples. Let's just kind of review just like super quickly here. The first example, right, it had n over 3n minus 1 converged to 1/3. You can see that the degree was the same on the top and the bottom, so it's just 1/3. The second one, it's really the same thing, though you don't really necessarily look at degree, but it was 3n over 3n, which is 1. That converges to 1. And then for that last one, you see the top was a quadratic. It goes, it's a lot bigger because if you simplify it with our limit down here, right, it was n over 2, which goes to infinity. Now, real quickly, too, if let's say there was a negative in front of there, just be careful, right? If there was a negative, then you would say negative infinity, okay? But, of course, that was positive. All right, so let's do a little more practice now on just to determine if the series converges or diverges, and then find the sum if it converges. So remember what you're going to do is you're always going to take the largest degree. So this is out of here, and this is out of here. And this is out of here, and this is out of here. So really, it's limit as n approaches infinity of that function. So it's really, if I simplify that, it would be 5 over negative 4n. And right when the degree is bigger on the bottom, then what are you going to do? It goes, like, the bottom gets bigger and bigger. Now I understand some of you guys are saying, well, Mr. Curvis, the whole thing is going to go, it's going to go to negative infinity in the bottom. But that doesn't really matter. Then it's 5 over negative infinity, which is still 0. Please, of course, don't ever tell me negative 0. That's like brutal. All right. So you're going to say it converges to sum of 0. Okay. So the next one, again, you're just going to keep the 3n cubed and the negative 5n cubed. And so you're going to say limit as n approaches infinity of 3n cubed over negative 5n cubed, which is just negative 3/5. Okay, so it's going to converge to negative 3/5. Okay, cool. This guy here, we got negative 6n cubed and 8n squared. So limit as n approaches infinity of negative 6n cubed over 8n squared. That's going to be limit as n approaches infinity. And again, I'm not going to reduce the 6 and 8. I don't really care. But I'm just going to say that you have negative 6n over 8. And then what happens is getting bigger and bigger. In this case, what is it going to? It's going to negative infinity. So it's going to diverge. And again, you don't need to fill that in because don't tell me the sum is negative infinity because it's not really a sum. Okay? Number 7. 7's a little tricky, but I want you to think logically. I'm kind of looking at the limit as n approaches infinity of 2 to the n over n squared. I guess the question I have to ask you is which one's getting bigger faster? Well, if you would type stuff in your calculator, again, I'm not going to bring a calculator up here now, but you can type it in. Let's use the number 10. Okay, if I did 2 to the 10th power for my calculator, I would get 1,024. And 10 squared is 100. So you can see that top is actually getting bigger faster. Let's just do 11. So 2 to the 11th is 2,048. And 11 squared is 121. So look at that, jump by 1,024. That jump by 21. So you can see the top is getting bigger and bigger and bigger. So this one is going to infinity because the top is getting really big faster. So this one's going to diverge. And it's just the reverse. This one's same thing. Limit as n approaches infinity of n squared over 2 to the n. And so in this case, the bottom is getting bigger faster. So this is going to be, if the bottom is getting bigger faster, it's going to go to 0. Because again, the bottom is going to get huge. So it's going to converge to 0. Okay, and then the last one here, just kind of a different problem. It's almost the same, negative 2 to the n over 2 to the n. So if I just like looked at let's put the number 1 in there when n is 1, just to see what's going on. Negative 2 to the first power, negative 2. 2 to the first power, 2. That's equal to negative 1. Let's put a 2 in when n is 2. Negative 2 squared, 4. 2 squared, 4. Put a 3 in there. Negative 2 to the third, negative 8. 2 to the third, 8. So look what's going on, math fans. It's going negative 1 to 1, negative 1 to 1. So when it's an even power, the top is going to be positive. The bottom's always going to be positive. So it's fluctuating between negative 1 and 1, negative 1 and 1. So is it going to a number? Nope, it is not going to a number. So if it fluctuates between numbers, then it diverges. Okay? So it diverges, and there's no sum. All right, so that's just a little more practice on limits to infinity. It kind of helps you again with the partial sums, and hopefully, again, this is not too difficult. You know, we learned a little concept of calculus and a little more pre-calc here. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.